if your dot product's positive, then it means they're pointing more in the same direction. All right, the cross product is the other type of product, and that's being asked about in I. The cross product does give you a vector. Again, it has some interpretations. It gets used in a lot of formulas of other things that we're trying to learn. And I know that there's some overlap between people in Calc 3 and people in linear algebra. This is actually a linear algebra process too, and so because it's more related to linear algebra, I will find, one of my linear algebra books has a good, if you really wanted to dig into what is going on in this process, it has a pretty decent explanation. I'll try to run that off for everybody, so. But today, I would worry about learning the mechanics, okay? So what you do is you build an array, also called a matrix, and you just kind of outline, I'm going to put my x's here, I'm going to put my y's here, and I'm going to put my z's here. So we have -5 and 7 are my two x's, 8 and 2 are my two y's, and 4 and -3 are my two z's. And we are doing this in 3D because in our class, that's pretty much what our class is all about. There is a 2D version, but we don't use it too often because we're working 3D. Again, I'm just mechanically explaining what to do. When we get done, I will point out a couple of things to kind of help you visualize what went on. To compute the I or the x component of my vector, I ignore the x's, okay? And I use the y and the z's. And I multiply this y with that z, so I would get -24. And then I subtract this z times that y. So it's these two get multiplied first, and then you multiply these two. You multiply these two second, and you subtract those products. So 4 times 2 is 8. And that gives you the coefficient of the x component of the vector. So -24 minus 8 is -32. That's the x component of my vector. Then to get the y component, you change sign. So there's a subtraction here. So this is positive. And you do the same mechanics, but you're subtracting. Okay, I ignore the y's, and I use the x's and the z's, and I multiply these two together first, and then I multiply these two together second, and you subtract in the middle, but the y term has an opposite sign. So -5 times -3 is +15, and then -28. Okay, +15, but then subtract 4 times 7. And so 15 minus 28 is -13, but then this will make it positive. Yeah, 28 minus 18 minus 13j. It's positive because of the negative on the outside. And then for K or Z, you do the same thing. You ignore Z and you just work with X and Y. Okay, so I ignore Z and I work with X and Y, so we multiply these two together first, and then these two together second, and I get negative 10, and then I subtract 56, and that will give me negative 66. Right, so that's the cross product of those two vectors.
It's been used a lot in physics, both like electronics and I think torque is.
Yeah, torque is the cross product of force and direction.